with the science, the chemistry and the structure of water molecules, right? And so when we looked at it, we have our O. We express it like this, don't we? And what did we say those lines represented? Awesome, nice job, okay? These are our lovely covalent bonds. Covalent bonds mean that we share electrons, and the reason they form is because oxygen has 6 electrons in its outer orbital. There's something called the octet rule from chemistry where you, except for the first orbital, which only has 2, every orbital wants 8 to make it happy, okay? So, octet rule, is happy for everything except for hydrogen. Hydrogen is super tiny. Hydrogen, to fill its orbitals, would need 2, but in reality, it only has 1. Okay? Just circling around it. Got it? So this is the structure. 6 on the outside, 1 on the outside of hydrogen. Now, to be happy, oxygen needs 2 more to reach that 8. Hydrogen only needs 1 more. So what happens is you'll see that it's going to share. Sharing is carry. Hydrogen's going to share because it's so close. And oxygen's going to share 1 of its electrons, and vice versa. This oxygen's going to share, and that hydrogen's going to share it. So that way, whoa, we're a big happy family. That is what covalent bonding is. It's just sharing, but it's enough of this force that it makes a bond. Okay? So we know that because of this, which has more electrons, the oxygen or the hydrogen around it? It's neutral overall, but where do most of the electrons reside? Where do most of the dots hang out? Which one? The oxygen. And what charge is an electron? Negative, okay? So that means that this oxygen carries more of that negative charge. Now we use this symbol to represent like the electronegativity, the pole of the negative charge. The key here is a negative. And that means that hydrogen, to be balanced, has more of the is more positive than that oxygen. Okay? And we know that opposites attract, right? And because of that whole opposites attracting, okay, that negative oxygen is attracted to positive hydrogens. And that is what leads to it getting close and forming attractions with each other. Okay? So, let's say, remember, polarity, polar just means uneven distribution, okay? Polar means there's some charge things going on within it. Polar molecules like each other. Other polar molecules. So they get close to each other. They get close to each other and form attractions. I'm going to call it plus to minus, like the positive and the negative ends. And what do we call those attractions that are formed between like the positive of one molecule and the negative end of the other? What do we call those strong attractive forces? Except they call it weak, I think, in yours.
Weak attraction
But what other name does it go by? It was a word that we used, and I said I hated it because it's misleading. Because it's not a true one of these.
Wasn't it hydrogen?
Perfect. Okay, so this attraction is called hydrogen bond. Now I underlined attraction, and I am going to write bond really faintly, kind of. Okay, because it's not like the word bond makes you think it's really tough, that they're actually physically connected, kind of. But really, it's just an attractive force. They just get really close together, and we modeled that last week. You cool with that, guys? A couple other terms. What's the prefix, or what prefix in words means water. What do we use? Hydro, like our hydro flasks, right? So hydro, there's two words I'm going to use. Hydro, loving molecules, like to be around each other. Do you guys know what the root for love is? Latin? Affilio. So we call it hydrophilic. Is water loving. Okay? Polar molecules are hydrophilic because they like to be around other water molecules and form these strong attractive bonds, these hydrogen bonds. Okay? Now, we said hydro is water. What do you think if it's water fearing? What do you think it's called? Perfect. It's the phobia of water. Okay? Hydrophobic means no. Just say no to H2O. Okay? Non-polar molecules are hydrophobic. Like that oil. Remember the oil didn't have any like uneven distribution of charge? Okay? Any questions about the chemistry? Hopefully that part was kind of review. Okay, next thing. It is these chemical properties though that are this chemical structure that leads to the cool characteristics of water, such as cohesion. The prefix co, if you look up over there, those that are on this side, can you see what co means? What's it say?
Together.
Together. Like cohabit. You live together. Okay? So it's when water molecules stick to other water molecules. Because they have that strong attractive force, right? They have that hydrogen bond going on. So it's like they stick to water. Stick to. Sorry, I left off of that. Stick to other water molecules. Okay, that is called cohesion. Cohesion should go in the bubble. On the flip side, we have another word very similar called adhesion. It still means sticking, but water sticks to other things. Okay? Cohesion leads to something called surface tension. How many of you have heard of surface tension? We're going to see it in action in a minute. It's when the water sticks to each other and it almost looks like it can be like a solid, like something can be on top of it because of those attractive forces. And in fact, that keeps the water together, and adhesion then allows for things like this guy, the Jesus bug, to walk on water because it's light enough. I gotta stop.